All right, ladies, so we're gonna get going. Just a note, again, most of our microphones are muted, so that'll help with background noise. But I want this to be Q&A, so definitely ask questions, please, so that we can go over what you're interested in going over. There's a couple of things I pulled out after looking at the practice quiz. So I thought we'd start by maybe going through some of those problems and then kind of go from there. So I'm going to share my screen. We're going to see how many things I can do at once. All right. There we go. All right. Now I think I can see you and see my screen. Okay, so let me get rid of this. All right, so one thing I wanted to review was going over the difference between a couple of terms. So frequency versus ratio, these are two terms that are commonly used in genetics. When we're looking at the frequency, we're looking at how often something happens. And since we're talking about genetics in this case, we're looking at the population and how often either a genotype or a phenotype comes up in the population. Sometimes we also talk about frequency at an ecological level. And that's something, if we move on to evolution, we'll take a look at. And looking at, you know, how do the genotypes and phenotypes play into evolution. Most genetic problems, like the ones you had on the quiz, are going to ask for a ratio of either a genotype or a phenotype, so like a numerical counting, if you will. And so I pulled the answer from the very first problem, just to point that out. So in the top case, the genotype ratio would be what I have up here at the top. So 2 big H, little h, and then I've got my colon and 2 little h, little h. So that would be the genotype ratio. I've got 2 heterozygous for every 2 homozygous recessive. And then my phenotype ratio would be 2 horns, because that's what the big H, little h gives me, to 2 no horns, which is what little h gives me. So just to clear up, if you weren't sure, you know, when it was asking for the ratio, exactly how you should write the answer, that's what we're looking for. Sometimes problems like this will also just ask for what is the percent. And then, of course, instead of writing this ratio, you could write, you know, 50% horns or a 50% chance of not having horns. So that would be completely fine. Again, chances of you having to write out the ratios on like the AP test are probably pretty slim. But just as an FYI, in case you see it in the future. All right, I'm going to pause. If anybody has a question about that, please feel free to unmute and let me know.
Wait, isn't it just 1 horn?
It should be 2. So I did leave comments on some people's work. Watch really carefully. So when I have this heterozygous individual, I know there was a couple people that accidentally forgot to not bring the big H down to both boxes underneath of it, which would throw off your numbers a little bit. So maybe just go back and double check that. So you should have 2 heterozygous individuals in the Punnett square and 2 homozygous recessive.
Oh, it just says like on my sheet 1 horn is dominant and no horns is recessive.
Oh, so the 2 horns, I don't mean like 2 physical horns. I mean 2 individuals with horns.
Oh, okay.
Yep.
Oh, okay. Because I was like, wait, what? Okay, thank you.
Yeah, no problem. All right, we'll take a look at the dihybrid cross. All right, so for dihybrids, like what went over kind of in the video, and we talked about a little bit with ratios, you can save yourself the trouble of having to do the Punnett square if you don't like doing them by figuring out the individual ratios. But the catch here is that it's still asking you for the expected phenotype ratios for this cross. So if you just worked out monohybrid Punnett squares with just the parents and did the T's separate from the C's, you would still have to combine those ratios to figure out how many different combinations can you get and what are the chances of getting them. So in this case, because of what they're asking for and because it's just a dihybrid, I really would encourage you to actually do the dihybrid Punnett square, so that actually in this case will make it a little bit easier. So if we've got these parents up here, and I just want to go over this quick in case you maybe didn't do it this way and you need a refresher about how to set up the top part where I have the alleles from each parent on the top and the side. So given this is our, given this is our parents up here, remember when we're figuring out what are our possible combinations, remember you've got to think about meiosis, and you've got to think about the fact that this big T and this little t are going to get split up. And we want to look at the fact that the big C and the little c are going to get split up, and how many different ways could combine those in meiosis. So I could do the big T with the big C. Imagine again that these are on separate chromosomes. I could do the big T with the little c. I could do the little t with the big C, or the little t with the little c. So these are all the possible sperm or egg cell combinations for these two alleles that I could come up with for this first parent. In the second parent, because they've got two little t's, they're always going to give a little t. So that's why the outside here for this parent just has little t's. So these outsides are the possible, again, combinations in the sperm or the egg and the gametes. But I could combine them with a big C, or they could get combined with a little c. So those are my combinations. So because of that, I really don't have to do these bottom two rows because they're going to be exactly the same as these top two rows. So it's redundant. There's no reason to do it. It would just take you more time. And if there was a situation like this on the test, you would, not want to use that time. You want to use it wisely. So then I put my combinations together. I always write my T's together and my C's together, went through and filled in the boxes. But the catch is, it's asking me for the phenotype ratios. It doesn't want me to give the genes. So I have to ask myself, what is this plant gonna look like? Okay, so it's gonna be tall, it's got a capital T, and it's gonna have colored kernels. So I've got to go through and count how many of those are going to look like that. So I've got one here, I've got one here, and I've got one down here. So that gives me 3 that are tall and colored. The reason why I've got a little 6 up here is because technically if you would have filled in the whole box, right, there would be 3 more down here. So you could either have 3 out of 8, or you could have 6 out of 16. And I went through and I did the count. And again, I wrote it like a ratio. So I've got the colons separating the phenotypes. So that's how you would write out the ratio for this. So if you did it with the monohybrids, again, it'd be a little bit trickier. I actually think it would be more work to go through and do the actual multiplication and the probability in this case, because it is only 8 boxes that you really have to do. So I would ask myself, what is less work? And in this case, I would say that this actual kind of half of a dihybrid Punnett square is less work for you. You might also notice that I have little check marks in my work. When I'm going through and counting, I always check off a box when I count it, so that I don't lose track. Have I already counted that yet? And remember, if I've got 8 boxes, I should be able to add up my numbers here in my ratio and get 8. If I get more or less than 8, I either overcounted something or I missed something. And again, if you did the whole thing, then you would be adding up to 16. Okay, so I'll pause there. Let me know if you have questions about how I did that one.
So could you put the ratios as like 1 to 8 and 3 to 8?
You could write them as fractions. If you wrote them as fractions, then I would probably just list them like 3 out of 8 tall colored, 1 out of 8 tall white, instead of separating with the colons. Are there any other questions for this one? Okay. All right. So we had incomplete dominance with our radishes. I think for the most part, when I looked at everyone's quiz for this, we were pretty good. I'll just show you kind of how I write it, just because we had a few different ways of setting this up. And if you didn't write it and set it up like I did, that's not wrong. Just maybe give you an idea of how you might see it from other people. So in incomplete dominance, I like to just write all my combinations, my genotypes and my phenotypes at the top, so I don't goof anything up. This problem did say that we had crossed a pure breeding red and a pure breeding white to make purple, so that's my big R and my big W. The reason why I use 2 capital letters is because that way it reminds me this is not Mendelian inheritance, right? This is different. I wouldn't want to use a big R and a little r, because that's might mess up my brain. So I want to use 2 different letters, and I have them both be capital. And I want the genotype and phenotype ratios when we cross that purple with that are white, which I set up over here. And then again, here are my ratios, my 2 RW to my 2 WW, and my 2 purple to my 2 white. But again, for the most part, I think everybody had that, so I don't want to spend a lot of time on it. I just kind of wanted to explain how I set it up, and this little kind of trick I do for myself to make sure I don't get mixed up. Does anybody have questions about that? And that works for me for codominance too. So incomplete dominance and codominance, I usually do pretty much the same. All right, blood type. I think maybe the only tricky part here that I wanted to point out, because again, this looked really good on the quiz, is that when you were figuring out the woman's blood type and that she was B, it did say that her mom has type O blood. So in order for her mom to do that, she would have had to have been OO. So given that, we know that this woman has to be BO for her blood type, not BB. That's the only way that that could have worked out. So you did kind of have to catch that and figure that out when you wrote out her blood type in order to get the correct answer. And in that ratio, it would have been 1AB to 1A to 2B. Now, granted, these B blood types are different. So when you do the genotype ratio, you have to count them separately because there's one BB and one BO. So that's kind of the one difference between the genotype and phenotype ratio here. But again, I think other than maybe missing that point about the mom and having to know that this woman was BO, I think we were good on blood type. When you write it, I tend to leave the I's out just because it makes it a little busy. But if you write the I with the superscript letters, that's totally fine too, because a lot of people do that. But for me, it's just a lot more writing on the page and it clutters up the Punnett square. So I usually just write the letters. And I'll write an O for O since I'm not writing the I's. Any questions about blood type? All right, and then on to sex-linked traits. Okay, so I wanted to run through this one a little bit. So we had to give the phenotype and genotype ratios of children from a man normal for blood clotting. So when we're writing out sex-linked traits, make sure you write the X and the Y, and then you add the letters. And I know I just told you for blood type, I don't usually write the I's, but sex-linked, the sex matters, we need to trace it. So I do write the X's and the Y. So just an FYI on that. So here's my male, XY, normal blood type. So I've got a capital H. I did write the cross up here at the top to kind of help me figure out what the female and male genotypes should look like before I cross them. And then we've got a woman who's a carrier. So since she's a carrier, she's going to have one X that has a big H and one X that has a little h. I went ahead and combined those in the Punnett square. Now this one said list the possible genotypes and phenotypes of the children. It didn't say, you know, give the percentages of how many males, how many females. So again, if we're going to follow how it asked for the information and we're going to write the ratios, I'm going to write my genotype ratios out here. So I've got 1 X capital H capital H. So this would be a female without hemophilia, and she's homozygous dominant. I've got 1 female here, X big H, X little h, that is a carrier, she's heterozygous. 1 male, again, that's normal, and 1 male that has hemophilia. A lot of times problems like this might just ask, what's the chance of being a female with hemophilia? So then you would just give a percentage. In this case, that would be 0%. There's no way to be a female with hemophilia. It might ask, what's the chance of being a male with hemophilia? Well, if they say male with hemophilia, here's my men, so I'm just gonna look at them, I'm gonna ignore the ladies, and I get a 50-50 chance. If it asks, what's the chance their child will have hemophilia, now I'm not paying attention to sex at all. I'm just looking at, out of these 4, how many kids could have it, and it's 1. So that would be, you know, a 25% chance or a 1 out of 4 chance. So sex-linked traits get tricky. You really have to pay close attention for what are they asking for so that you know what to give. I would say that's probably the hardest part of a sex-linked trait, is just really watching for what do they want in an answer to make sure you give them the correct information. Questions about sex-linked traits? Okay, so now I'm just going to open it up to questions. I can switch out of this. I can go into a whiteboard. We can talk about more Punnett squares if you want. We can talk about pedigrees if you want. So this is kind of just your chance to ask me to go over anything that you want.
Wait, I'm still kind of confused on how to trace back a pedigree.
Okay.
Like going like backwards and finding what the parents and grandparents were.
Okay, great. So I kind of anticipated maybe someone would ask about pedigrees, so I kept these 2 in here that I had done the video on. So we'll kind of stick with this one first. So what I do first is, you know, it kind of depends on the information they give you in the pedigree. Like for instance, the second one, I knew right away that this was sex-linked, even if I hadn't known about hemophilia being sex-linked, because of this carrier female up here in the key. So that does kind of help me know, oh, this is a sex-linked trait. If I look back at this one, this could easily be autosomal, so non-sex-linked, or I might be able to justify sex-linked. But I just kind of have to figure out, you know, depending on a question, what might be going on. So this one's a little bit more uncertain without information. So I'll be honest, this one's a little harder to figure out without information about it or about the gene that they're tracing. So for instance, if I'm looking at this, my gut reaction to the fact that this might be sex-linked is the fact that there's so many males that have it and only one female. So that would kind of take my gut to sex-linked, because that's pretty common with a sex-linked trait. So what I can do here is I can just kind of say, all right, let's see, I have these two parents here, okay, a male and a female. Neither one of them had the disorder, but they have a son that has it. They have a son that doesn't, and a daughter that doesn't. To me, to figure out how could that work, if it's a sex-linked trait, mom could be a carrier, and she gave that gene to her son, and then dad gave the Y chromosome, so that could be how he got it. This boy could have gotten mom's normal gene, her X chromosome with her normal gene, and the Y from dad. And then this daughter could have gotten the normal gene from dad, and could be the normal or the affected gene from mom. We don't know, because these aren't half shaded. So that's kind of the thought process that I go through. Kind of the same thing works up here. If dad has the disease and it's sex-linked, he's going to give the Y to his sons. So there's no way that any of his sons would get that disease from him. So that would explain why these two sons don't have it. If mom's a carrier, she could give genes to her daughter here or here, and they would be able to then pass that on, like to this son. So it's a lot of trial and error. I really write on these a lot when I'm trying to figure out what I know, what I don't know, to work my way backwards, depending on maybe what question I'm being asked or what they're asking me to determine.
Can men be carriers?
Men cannot be carriers of a sex-linked trait, because the sex-linked traits are normally on the X. And since they're only going to have the one X, if they have the gene, they have it. There's a couple disorders we know of on the Y chromosome, but again, if you're a male and you get the Y chromosome, you've got it, so you're going to have the disease. So men can never be carriers. Are there any other pedigree questions while I've got them pulled up? Okay, so do we have any other questions then that you want to go through? I can do another practice problem. I can pull up a whiteboard. Is there anything else?
I was wondering for the AP test, is there any more like units that we need to still cover?
This genetics is the only unit we've got to finish up for what's on the AP test.
Okay, so we're
So-
pretty much done then, so we can start reviewing.
Yeah, absolutely. I did post that review guide last week. So yeah, that's why I really wanted to get genetics over with this week and next week and get through all of that. So I knew that at least by next week we were covered and we were kind of good to go. But yeah, so once we're through genetics, we'll technically have been through everything that's going to be or could be on the test.
Okay, and then do you know the format yet of the test or not?
The test is going to be a 45-minute free response test. Yeah, so there won't be multiple choice. There could be mathematical calculations you have to do within a free response, so that is a possibility, but there won't be any multiple choice questions.
Okay.
And it's going to be short because it's only 45 minutes. The free response section is normally 90 minutes long.
So is that going to be like one question then?
I don't know. They haven't given us any specific information yet. They're supposed to release more information at the end of the week.
Oh, okay. Thank you.
Any other questions? Okay. Well, I recorded the video, so I will upload this and then attach it to Google Classroom. It'll just take a while for the video to process in case you want to go back and look at anything. Tomorrow, I'm going to post some information about chi-square. And then Friday will be the chi-square lab, and we'll kind of just start the first part together, and I'll answer questions you have about chi-square, and then you'll be able to finish up some of the calculations and share your work with me so that I can give you feedback. So that's kind of the plan for the rest of the week. All right, awesome. Well then, if you don't have any other questions, feel free to head out. If you've got like an individual question you want to ask, you're welcome to stick around.
Oh, are we gonna have any more tests this year or
It's
quizzes?
going to depend on what happens after next week. So if we're going to stick virtual for the rest of the year, we will still do kind of a modified midterm. I'll probably do it through AP Classroom.
Okay.
But if they decide to call it, then we'll just go with what we have.
Oh, are they thinking about actually just calling the school
I don't
year?
know. That's just worst case scenario. We have no idea what the Department of Ed is going to do. We're all just kind of planning for the worst case and then hoping for that not to happen. But
Yeah. Also, do we have any quizzes up right now on AP Classroom?
yeah, so I opened up all of the multiple choice and free response for every unit, 1 through 6, which are the ones they're going to test you on. They're
Okay.
all available for you on AP Classroom right now. The multiple choice one should give you your results right away. If you do a free response, just email me and let me know which one you did so I can go in and grade it for you.
Okay, perfect. Thank you.
All right, go enjoy the sunshine.